Altair is a global leader in computational intelligence that provides software and cloud solutions in simulation, high-performance computing, data analytics, and AI. Altair enables organizations across all industries to compete more effectively and drive smarter decisions in an increasingly connected world, all while creating a greener and more sustainable future. Julian will be able to offer some more information on the benefits that Altair is providing to GoAERO teams. So thank you so much.
Good morning, everyone. The last presentation before lunch, I think, so we'll try and keep that quite dynamic and short. My name is Julian Chaussee. I work for Altair. I'm a senior aerospace specialist. So what does that mean? That means my role is to sort of connect aerospace companies and aerospace customers with our tools and help them leverage our solutions. So my background's very much aerospace. I spent 15 years before joining Altair in the aerospace industry, working for Airbus and working for Bombardier in sort of advanced design teams, looking at next generation aircraft, next technologies, integrating all these technologies into aircraft and things like this. So that's kind of how I came to it. You might be wondering, I don't know how many of you know Altair, but you might be wondering who Altair is. So we're a technology company that was founded in '85, headquartered in Troy, Michigan. And we're very much an engineering, sort of technology company. We're designing software and providing software for engineering simulation and AI for many different industries. We have many different products. And we work with most of the big aerospace and defense companies out there, we've been in business 40 years and we've been doing that. We were recently acquired by Siemens a couple of months ago, actually, and we're now part of Siemens Digital Industry Software. But really, the foundation of Altair was very much around that idea that simulation could do so much more than just validating products after they were designed. But you needed to be able to create those simulations quicker and get access to them much earlier in the design process. And we've spent 40 years designing solutions that enable people to design products quicker, get through many, many, many more simulations, and really get to understand their products, whatever product it is. Try and go through this and find what's the best design, what's the best structural layout, what's the best system. And we really came to the idea that you need to not only leverage simulation, but today with AI and data science in general, you can really get even more out of your company, out of your simulation and your engineering data. So the idea was, how do we piece all this together to enable you to make those design decisions informed by simulation rather than just live with the design decision that you've made and then sort of analyze them. So we want to make it much faster to turn around those cycles. And, we like to say that, we're the data science mixing rocket science company. We really like to sort of merge all these technologies and enable you to design faster. So we're obviously a software provider, but what do we bring to the table? And I think this is relevant to all the GoAERO teams here, is obviously we bring many different simulation. We have one of the broadest portfolios of simulation technologies out there, whether you're doing CFD and that kind of, or structural simulation or system simulation, electromagnetics, all this kind of thing. So we have well-proven simulation technology. We've also spent the last, few decades combining this simulation power with data science and all the AI that we hear about now to try and push it further and to really mix it together and obviously provide high-performance computing solutions, because you cannot do that level of simulation without that kind of thing. But I would say one of the things that's probably most important, and I highlighted those two things on this slide. Two of the things that we bring that's should be more valuable to you guys is the open architecture solution and the industry expertise. And why am I saying that? Well, let's be honest. I've been in your shoes before. I've worked on many different projects that were fast-paced, very small teams, at work and outside of work. And one of the things that's going to come back, time and time again is your process is not linear. You're going to have to iterate. You're going to have to change direction. You're going to have to revisit your design. So you need to work very quickly. But also, you're going to be working with very small teams. You can afford to have an expert for every domain, every physics, every aspects, you may end up having people that join the team and they come with their own expertise and their own software and their own abilities. And really, this is where the open architecture comes in. We don't want to lock you in. We don't want to say, hey, you use Altair software, you're stuck with this, We have always prided ourselves on having probably the most open architecture out there where you can use our software, but we're cognizant that we don't have the best solution for every product, as much as our sales team would probably shoot me down for saying that. The reality is you're going to need to bring different solutions out there and different things, and we enable you to do that. The other thing is, like I said, you're not going to have experts in every domain. You're on a fixed timeline. You have reduced teams. So what we try to do and what we've always tried to do with all our customers is to share the expertise that we have and to help you get to a solution faster. You're the brains behind your design. You have lots of bright ideas. Our goal is to give you the solutions and the tools that you need to deliver those ideas, to study those ideas, and to get them through. So what I'm going to show you next is some examples of some of the tools we have and some of the solutions that you have access to. But if you're going to retain anything out of my presentation, these 2 points are key. Working with an open architecture allows you flexibility to bring in other solutions as and when needed and leverage our expertise. We're not just a software provider. I can give you a license and that's fine. I can disappear if you don't need me. But do reach out, because this is really where we can help you make a difference. You're on tight timelines. Let us help. Let us guide you how to best use the solution. There's no way you're going to spend your entire project learning new software every time you need something. You need the kind of tailored guidance that will allow you to learn enough that you can get out of it, get what you need out of it, not become an expert. So by all means, do reach out. So what I'm going to show you now is a few examples of some of the solutions we bring to bear to help you with that. And obviously our most sort of known simulation solution is our Altair HyperWorks platform, which encompasses all our simulation technology. But whether you're looking at whatever part of the aircraft you're working on, whatever system you're designing, whether you need to do aerodynamic simulation, structural simulation, very quick turnaround, sort of frequency analysis, whether you're doing systems level design, requirements management, power electronics or avionics, and we'll go through some of these things in a bit. And I'm going to show you some of these examples. Maybe one of the best illustration I have of the kind of solutions that we can bring that helps you speed up your turnaround time is on our CFD side. We acquired a company last year called Research in Flight that makes a very innovative panel method aerodynamics code. It's actually considered a mid-fidelity or low-fidelity aerodynamics code. But it brings a lot of value, and for me, it's the perfect example of how you sometimes need to pick not the highest level of fidelity, not the best technology, the most detailed simulation, but how you can actually use much quicker turnaround and come down in the fidelity, still get the results that you have without spending months trying to do this. So what is FlightStream? FlightStream is essentially it's a panel method, but has been completely reimagined. And if you plot on a graph the relative time for preparing the model and analyzing them on the lower side, and on the vertical axis we plot the fidelity and the level of accuracy. Traditionally, the low-level methods, so if we look at things like all the lifting line methods and vortex lattice methods, these are low fidelity and obviously run almost at the speed, like almost instantaneously. But if you look at the trends in simulation today, we tend to go in that level there. Super high fidelity, requires lots of computing power, much more detail, but also requires a lot of expertise to run properly. What we've tried to do with FlightStream is bring the panel methods to a level that is acceptable, but make it so much faster than a lot of these high fidelity methods. And because of the simplicity of the code, it enables you to do things that you can't do, or you will struggle to do in the sort of timelines that you have. And if you look at the capability, and this is where it'll be interesting, the kind of speeds that we cover are probably irrelevant to you guys. We cover anything from incompressible flow to all the way to hypersonic flows. Not very relevant. But where it's really important for you guys is how you can very quickly with this system, because there is no volume grid, there is no super complex meshing or model preparation required. You can very quickly iterate through your wing design and your control surface layouts. You can very quickly deal with models that have a lot of close proximity and rotating parts and moving parts and that kind of stuff. You can even do unsteady, so time domain simulation with compound motion like the V22, where you have both the rotation of the rotor and the tilting there. So a lot of these things, and you can even do 6 degrees of freedom. All this is done actually very quickly with very little preparation time. And as much as today you can run a higher fidelity simulation within 20 minutes, we can run an entire curve in 20 minutes. And you don't need the level of expertise in model preparation that you need for the more advanced methodology. So this is a perfect example of how you leverage something that's maybe lower fidelity. It's not as sexy as doing the super fancy flow around an aircraft with all these nice turbulent, vortices that we plot today. But it allows you to do that, to do super complex simulation very quickly. And on a desktop computer, you don't need, 4 GPUs or 5 GPUs in the cloud to be able to do this. So this is a perfect example of the kind of stuff that we have. If we look on the more structures and more sort of hardware side of the design, we talk a lot about, Altair is famous for its topology optimization and that kind of solutions, but really we turned this over the years into full-blown simulation-driven design. And I really like the term simulation-driven design because it's really about the simulation enabling you to get the best designs. And that takes many different forms. It's about enabling rapid sort of kinematic modeling, thermal modeling, whether you do some structural analysis or optimization, whether you need to do crash simulation or even systems level design. So 1D simulation, math, so complex, integrated, multi-physics simulation. And we'll bolt onto that design explorations and manufacturing and that kind of things. And here's a quick example of a customer using our motions dynamic tool to design a morphing wing on a UAV. So this is the kind of stuff that you can very easily do with the system. And the beauty of a lot of these tools is they're fairly easy to learn, fairly quick to learn. And nothing's easier to learn than our Altair Inspire tool, which is really turned from a platform that initially was doing just topology optimization into a platform where we can now set up multi-body dynamic simulation very quickly. So if you have any kind of moving parts, and we can even support flexible bodies now, which means you can do multi-body dynamics with non-rigid bodies. One of the most brilliant innovation we brought in Inspire is the implicit geometry. So if you look in the lower left, creating those lattices, and honestly, we always show implicit geometry with lattice, but it's a big disservice to the technology because implicit geometry can do so much more. It's a very different way of thinking of geometry modeling, but it enables you to do very quick things, including that heat exchanger that we've got there. And one of the things we added to Inspire recently is a GPU-driven CFD code that will run on a desktop with a fairly good GPU, and can now take implicit geometry mixed with other type of geometry. So if you want to do those really nice cooling flow in lattice structures for thermal management of your different systems, you can very quickly do that with almost no model preparation. It's really impressive what they've built. And Altair wouldn't be Altair without the optimization side. Pretty much every technology, every physics we model, we can optimize on. And we started with a lot of things around topology optimization and concept design iterations. But we can talk about lattice structures. We can talk about different types of optimization, whether it's topology, topography, shape optimization, size optimization. And if you do a lot of composites, we have a pretty nice composite optimization workflow that will help you. So all these are kind of very useful tool. We've also, if you want to do some concept level architecture optimization, we've developed a process called C123 where we gradually increase the level of complexity of the optimization, and we use that to do sort of overall architecture, structural layout kind of optimization. And this is an example, a very early example of one section of a helicopter that was done with Airbus helicopter way back. And tomorrow I will be presenting at the VFS a concept level optimization model for sort of an advanced air mobility fuselage. So this is the first step in a process that we're developing. This is kind of a first preview of what the technology, what we intend to do with the technology, and how we intend to evolve. And it's not necessarily evolving the technology, the optimization technology, but it's evolving the way of leveraging it and how we make those models more accessible. And obviously, some of the key advanced optimization technique that may be of use to you, things like fail-safe optimization. So how do you do topology optimization, optimize your structural layout, accounting for failure? Whether it's multi-model optimization, if you have a reconfigurable vehicle where you need to have different sort of layout and quickly reconfigure, how do you take that into account when you do optimization? That kind of thing. We obviously have a lot of capability to do crash and safety analysis, whether it's crash testing, drop testing, any kind of impact, and even lightning strike we could do actually with our electromagnetic solution. So that kind of stuff you will need to do at some point, and we're pretty well equipped for these kind of things. In terms of electromagnetics, we talked, there was a lot of talks in Rex's presentation about communication and different systems that need to be. All of these require antennas and different systems that talk to each other or don't talk to each other. That kind of things. We have a very complete electromagnetic solution that will sort of enable you to look at different systems, how to place your antennas in your vehicle, even also how your different systems talk to each other at the system scale, not the aircraft scale, that kind of things. And here's a study we did where we combined different approach from aerodynamics and structures and also antenna design and radome design, like to design a radome to make sure that it didn't sort of decrease the performance of the antenna. Briefly, integrated propulsion. I know most of you will be looking at electric propulsion, so if you need to do motor design, if you need to do battery design, probably you'll spend more time on this kind of things, whether it's about understanding the thermal management of the battery, the cooling plates. We can do topology optimization of the cooling plates, for example, but whether it's crash simulation of the batteries, make sure you don't have a thermal runaway and a fire that would make it much worse. Whether you're looking at designing your power electronics to control all this, or even sort of all your powertrains, so the blades and the gearboxes and all that kind of stuff. All this is available. Here's an example, and just to show that we don't just design software, we also try and understand the applications. This is a digital twin of a battery that we built. Well, we built the physical battery, and we simulated a thermal runaway case and show the simulation and the digital twin sort of follow quite closely the behavior of the battery. So that allows you to essentially predict what's going to happen and hopefully shut down the system before it gets too bad. I won't spend too much time on data and AI because I think for the kind of application you have, first you need to generate a hell of a lot of data before you start leveraging this. There's probably some use cases that will be of use to you guys, but we obviously do a lot of that kind of stuff. Once it's deployed as part of the strategy of managing the system in service, that's where there's maybe some value and looking at digital twin and digital platform to follow your system. So trying to predict the behavior of your system, trying to predict failure, trying to predict all that kind of stuff. And we have a lot of capability to add sensors to your systems and to have the digital replica and really run a full digital twin. And I'd say now we're part of Siemens. This capability is going to be even greater. It's really a question of understanding how you can improve your system later on, and how you can operate. That's pretty much my last slide, actually. So that's good timing. Now, it's all well and good. Presented all sorts of tools you can use. How do you get access to this? It's very simple. You go to that website at the bottom, and you'll be able to apply for a license for your team. We provide full licenses of our solution, all the Altair solutions. You get access to the training website, the training material. You get access to forums that are where you can ask questions and have discussions, and they get answered by our experts. And to be honest, you get access to us as well. So like I said, feel free to reach out to us. Feel free to ask questions. Obviously, there's only so many hours in the day. We can't just spend our entire days working alongside you, but we will do our best to help you get the right solution. That's really the promise I can make you. We will share the expertise that we have, and help you get to where you need. Obviously, what we ask in exchange is you recognize Altair as a sponsor and you display our logo on your aircraft, and you have it. But really, like I said, our goal in there is to enable you to deliver on your ideas, and that's really the key message I want to give you there. And we'll try to help you as much as we can. That's pretty much all I have. I'll take questions if there are any. Yes?
So we would get access to the duration of the competition?
Yes.
Early 2027.
Yes, and obviously you get access for the sole purpose of the competition.
Yeah.
Don't start a side business and.
Also, HyperWorks, do you use HyperWorks as well, or do you want certain packages?
You get access to all the packages.
Is this a cloud solution, or is it a desktop solution?
You actually have access to both, but yeah, it runs on desktop. You don't have to run everything in the cloud if you want to stay away from the cloud, but not everything is in the cloud. There are some cloud solutions.
What OS on desktop?
We run Windows and Linux. No Mac, unfortunately. Any other questions?
Thank you so much.
You're welcome.